Welcome to Unreal Gems. In this video we are going to be shading Citrin's body. In order to do that we are going to use subsurface scattering and other advanced techniques. Roll intro. Okay, so here we are back in Unreal, and this time we are going to take a look at the shading of the body of Citrin. So let's go ahead and jump into the material in which we are gonna dive into skin and other new types of texture maps that are going to be needed for this material. Okay, so let's take a look first at what we already know. So base color is multiplied by the ambient occlusion as in the video before, and then is connected to the base color ping, so it's quite simple as you can see. And then the AO map, it's also multiplied by the specular value, which you know that regulates specular highlights, and then it is connected to the specular ping. But this time in the material we have some new texture maps. Instead of using parameters for metallic and roughness, we are using texture maps. In this case, we don't have a constant roughness value or metallic value, so we need to use textures so that we can vary all over the surface the metallic value. So for example, in a sword, we will have 1 in the metallic, and for the clothes, 0 in the metallic. The same thing goes for the roughness. Again, here we have another map that will allow us to vary the roughness all over the surface and make things more or less rough depending on the value. So again, we are going to sample properly both texture maps. These are mathematical parameters, so let's go ahead and deactivate sRGB. I already did it, but remember to do that, and the compression stays the same. So remember that we have, depending on the map, this time the roughness map, we are also going to have to sample it properly. So let's keep compression settings the same and deactivate again sRGB, because this is a physical parameter, it is not a color, so you shouldn't activate it. Remember that values close to 0 are a polished surface and close to 1 are rougher surfaces, so they reflect light less evenly. Remember that in the metallic map, a value of 1 means metallic and a value of 0 means not metal. So it's quite easy, that is pretty much it. So let's go ahead and take a look at some new things. For example, the emissive component. So we just connected a texture with the emissive color to a multiply to be able to modulate its intensity depending on that emissive parameter, because sometimes you want more emissive or less emissive. Okay, so here we have a color like in the makeup or the skin, which is brown, or some parts which emit blue light. So as this is a color, you are going to have to activate sRGB, and we are going to have to keep the compression settings as default. As you can see, with this, you are going to be able to fake emissive lighting from the material. Again, the multiply is connected to the emissive color as with the other texture maps. Once we have this working, let's go ahead and take a look at how it behaves in the engine. So here we have the material instance with all of the texture parameters, which we are not gonna switch, because you can see that we have AO, base color, emissive, metallic, normals, which we have already seen, roughness, and also subsurface scattering, which we'll talk later. But the important thing here is the emissive parameter, because it's what we are going to modify to see the effect that it has. Bear with me, because I'm going to turn it up quite a lot, so it's going to look kind of horrible, but I need you to see what it means. So as you can see, as I turn it up, the character starts glowing with this yellow tint, which is horrible, but you can see where the map has a certain color, it's going to emit light of that color. So if we go down again to 0.5 or something less obvious, you're going to see that the effect is quite more subtle and it is quite better. This effect is useful when our character is in shadow and we want the skin or some details to be a lot more apparent. So in this case, as you can see, I'm going to turn it down and disable it using 0 or using 0.00 something, because I think it looks okay as is. We don't need any more emissive, any more light, but sometimes you can see in stylized characters and environments that the emissive is used so that we can see the color even in shadow. Again, the specular is going to be quite subtle, so you may not be able to appreciate it in YouTube, but a specular of 1 is going to make the specular reflections more apparent, and a specular of 0 is going to kill the specular reflections, which I think is a mistake. Sometimes people in stylized characters go ahead and turn it down to 0 so it does not have specular highlights, but I don't think that's the way, because a little bit of specular highlights are the normal thing, so having them completely disabled makes for an unnatural render. Where you can see this effect more is in the curved surfaces, and as you can see, everything looks good in the rest of the body, so I'm keeping it as is. Let's go ahead and take a look at the rest of the material. As you can see, the subsurface scattering map and normals is the only thing that we have left. Since we already commented on normals on other videos, you just have to plug it into the normal ping, and that's pretty much it. Let's go ahead and take a look at the subsurface scattering map. So here we have another mathematical type of data. So not a color again, so no sRGB check. 0 is going to be non-translucent, and 1 is going to be where the subsurface scattering happens, so where the light penetrates the skin. As you can see, it is only active in the skin. We usually don't use 1 or 0, we use intermediate values depending on the thickness of the surface, but here, since we have a stylized character, we simplified it. Compression settings again are the same, and as I mentioned, sRGB is unchecked. Once we have this, we can connect it to the opacity pin, which is not intuitive because there is a subsurface color, but we are not going to use it because that is for another type of shading model, which is less advanced, and we are going to use subsurface profile, as you can see on the left. As you choose that, you're going to need a subsurface profile asset, which is what you see here. In this case, this is one I have created for Citrine, but you can go ahead and create yours. Go into materials, and inside materials you have subsurface profile. You can also duplicate an existing one from the content samples of some other character, and you will be good to go. So once we have this, we are going to take a look at how this type of material behaves. So let's go ahead and take a look at the different parameters. As you can see, I have modified quite a bit. If you are looking for a deeper dive into subsurface profiles, go ahead and check out my translucency and subsurface scattering video. I will detail everything in way more depth than in this one. Okay, so the surface albedo should match the base color, and then we have the mean free path color, which is going to be what is going to make a certain color apparent when light penetrates the surface. So in this case, as you can see, I have chosen a non-realistic color because this is a stylized character and I'm kind of breaking the rules and not adhering to like physical properties or anything. You can choose the color that you want, but typically it would be red or so. So here, as you can see, I chose kind of a purple one because I thought it looked good, but you can go ahead and do whatever you want. So once you are satisfied, you can go ahead and click OK, and then you have the mean free path distance, which is kind of like the quantity of subsurface scattering that it's going to occur in the surface. As you can see, as I turn it up, the mean free path color becomes more apparent, and this is more or less the effect. You can also choose the world unit scale, but usually you don't have to modify it. I'm going to go ahead and leave it as is, as I had before, because I think it looks better. But as you can see, we don't have to be too exaggerated. It looks good anyway if we have set up the character properly and the scene properly. So as I mentioned before, no need to change world unit scale, but I did anyways because I thought it looked better. But usually if you have a normal proportion character, you don't need to fiddle with that. One of the most important parameters is the tint color, because if you want to make a color more apparent, you can do so with this parameter. Let's go ahead and cancel it and turn up the mean free path distance so you can see it better. This color is going to be multiplied by the subsurface color, and it's going to tint the subsurface scattering with the color that we want. As you can see, the green looks kind of ill, but I just selected it so you could see it better. Usually you will choose a more reddish color, like in the mean free path color. So with that, there are a lot more parameters, but since this is an easy video, I'm not going to dive deep into all of them, but I want you to know about the dual specular, which is also quite important, which makes the skin look a lot more waxy or less waxy, more like you are sweating or not sweating. So you have two roughness and the lobe mix, which will switch between the two of them. So you want to set them to different parameters, and then with the lobe mix regulate. As you can see, the specular reflections are gone if I choose a high lobe mix, and if I go down, the skin looks a lot more sweaty, a lot more greasy, but you can select whatever you want. I'm just going to go back to the parameters that I chose before because I think they look pretty good. So let's leave them at that. But as you can see, the subsurface scattering is looking pretty good, but you need to be careful and not only use subsurface scattering in the material. You need to choose in the light source, in the advanced parameters, to activate transmission, as we see on the right. We'll see that more in depth in the scene setup tutorial, but just bear that in mind. If you don't turn that up, you won't see anything. So with that, we have come to the end of the tutorial. As you can see, it is quite a simple material, but it covers all the bases that we need. So that's it for this video. As you can see, the material is more complicated, but I think the difficulty is still manageable if you understand correctly what we are doing. We have used advanced techniques like subsurface scattering and others, but as you can see, they are not so complicated. If you are in doubt, remember to take a look at my PBR shading series. It will clear a lot of things up for you. If you have found the video useful, please go ahead, like and subscribe. We'll see each other in the next videos in the Citrine shading series.